Hey, Thomas here. This is a math video that I'm making in response to a red pen, black pen, red pen um, video that is about an integral. The integral looks like this, and I'm going to try to see if I can solve it here. I think I can. This video is already 2 years old, so probably someone else has found a good solution, but I was wondering when I watched the video first, when I first watched it, I was wondering why he doesn't just reverse engineer the derivative, because the solution here is known as being negative square root of sine squared of x times cotan x plus c. So we know that, and black pen, red pen is showing that by differentiating this side, you actually do get to this side. And in the process of doing that, what he's doing is the last step before the final step, he comes out with this thing. Cosecant squared minus cotan squared dx. So this is the last step as he differentiates from here to here. From here, differentiate this and get the inside here, the integrand out of that. This is the last step before he gets right to this, and that's because he can do that because this here equals to 1. Why does this equal to 1? That's because in the third triangle, I call them 1, 2, and 3. In the third triangle, we have cosecant on this side, that's the hypotenuse. We have cotan on the bottom, and we have 1 over on the side. So you can see here, if this is the hypotenuse, then 1 squared plus cotan squared equals cosecant squared, or cosecant squared minus cotan squared equals 1. So this is 1, we know that. So now, knowing that, I was thinking, why not just take this and multiply the original integrand by a form of 1, here being cosecant squared minus cotan squared, and then go about it by separating the integral. So if I separate the integral, I get 2 parts. One is going to be this one, so that my O's look like S's, and my S's look like O's, and my C's look like O's, and everything looks the same. So cosecant squared dx, and then I subtract from that the second half. Let me make this a little bit better. I have this slippery tablet here, and it's really difficult to draw. I don't have that bad a handwriting, but so this is squared here, squared, okay, times cotan squared, okay, dx. All right. So this is the same, right? This is just splitting up this integral here into 2 integrals. That is now a difference of integrals instead of a difference in the integrand, all right? Okay, fine. Now, I'm going to just work on this portion first here, on this first integral, and I'm going to solve it using the DI method. So the DI method involves picking one of the expressions that are here in the integrand as the part that's being differentiated, and I'm going to actually pick this one to differentiate, and the other part is going to be integrated. Okay, so this is integration by parts, and I really like this DI method that is introduced by black pen, red pen. Other people call it something else, so we know it works, and it's nice and organized. So we're going to take take the derivative on this side, and we're going to make the integral of this one. So let me do this on the side here, because this is going to take a little bit of space. So over here, I'm just going to do the differentiation of this side over here. So d dx of square root of sine squared of x. And that equals, so square root is the outside. So 2 outside or 2 inside functions, right? The outside most is the square root. The next one is squared, so sine squared, and then the inside is sine. So let's do it from the outside to the inside. The derivative of the outside is something over square root, and this is going to be here sine squared of x, and that's going to be 1/2 of this, right? Because this is like to the power of 1/2. All right, so 2 times, and now I'm going to, so this is going to be 1 over is the outermost derivative. Now I'm going to do the second one. That's sine squared of x, pull the 2 down, that gets me the 2 here, and write the base of the squared. Okay, so 2 sine squared, that's the second layer, and now I have to still do multiply this by the derivative of the inside, so that's sine squared, so that's cosine. I mean sine x, that's cosine x. So that's it. Okay, now this, there are a couple of things that can be canceled. That's the 2. Now what I'm going to do is I'm going to rationalize the denominator. So I'm going to multiply by sine squared of x, top and bottom, like so. And what that allows me to do is then write the denominator as sine squared of x. And on the top, I have sine x times cosine x times square root of sine squared of x, like so, right? Now I'm going to cancel one of the powers here, one of the factors of sine x against this sine x, and now I'm left with cosine over sine times the square root of sine squared of x. Cosine over sine is the same as cotan, right? Because here you can again go back to this triangle here. In the cosine over sine triangle, cosine and sine triangle, cosine is here and sine is over here, and 1 is over here, right? So now you can see the ratio cosine over sine equals cotan over 1, cotan over 1. So this is just cotan, cosine over sine. This is just cotan x times this square root here. All right, good. So this is actually what I want to bring back over here. Oh, notice one mistake here. There were some mistakes. There are always some mistakes. This is supposed to be a minus. Okay, so here we go. So I want to write this over here. This is my derivative of that, cotan times sine squared of x. That's the derivative. Now over here, I'm just going to do the integral, so antiderivative, and that's going to be negative cotan of x, right? Because derivative of cotan is negative cosecant squared, so the derivative of negative cotan is cosecant squared, right? Going back into this direction so you can see what it is. All right, now I'm going to put my rewritten integral together, or the solution, the integration by parts together. So this here, and remember, we're just currently dealing just with this integral here. We haven't touched this here at all yet, but we're not going to. So this is just my side box here. Let me see how much space I have. I think I need 2 more lines and I'm done. So I'm going to rewrite this up here, this here, right? That comes down here. This integral, just this integral here, is going to be sine squared, square root of sine squared of x, but here's a negative. So I'm going to carry the negative forward this way, and then I have square root of sine squared of x times cotan x, okay? That's the direct here, this is the uv, or the, yeah, that's the uv. And then minus, but here's also a minus. So I'm going to multiply these two here, and that's going to be an integral. That's minus times minus, so that's plus, and an integral. And I'm going to start writing from here, from the square root thing again. Square root of sine squared of x times cotan squared. Right? I have two factors of cotan. Here's one, and here's another one. So that's cotan squared of x and dx. And so now this whole solution already stares us in the face. I want to come out with this here. And this is exactly what I have already right here. So that's that. But now I have plus this thing here. And this thing here happens to be exactly the same as what I haven't touched yet up here. So these actually cancel. And then I can just write equal. So there's one, it's like I'm kind of a stickler for equal signs because I always like to write equal signs where they belong, and this doesn't really belong there. So this is just for the inside, and now I'm actually going to go back up to the top here and take this away so I can make it clear. So now this equal sign here for all of this all together is then going to come out to just negative square root of sine squared of x cotan x plus c, and I'm done, as Black Pen Red Pen says. All right, that's it. Thank you for watching.